Okay, so today we're going to talk about section 11.4, which is conditional probability. It's the last probability that we're going to talk about in this chapter. And conditional probability is defined as the probability that an event will occur given the knowledge that an event A has already occurred. So given that one event has already occurred, we want to find the probability that a second event will occur, or what the probability of this second event occurring would be. So conditional probability is wrote as the probability of B, event B, and then this vertical line means given event A. So this is the probability of event B given that event A has already happened. And we can write this as the probability of event A and event B divided by the probability of event A. And we're going to use this equation, but we don't always have to use this equation. So in example 1, we're given a table. And rather than using the equation for finding conditional probability, we're actually going to just use the table. So in problem 1, we're told the table shows students by gender at 2- and 4-year colleges and graduate schools in 2005. You pick a student at random. And then part A wants us to find the probability of a female student given that they're attending graduate school. Because again, we have our vertical line which tells us this is a conditional probability. So the way that we're going to use the table is we're going to use our given thing, which in this case our given is graduate school. So we're going to focus on the graduate school numbers. So our graduate school numbers are going to give us our total set that we're interested in, because remember that probability is the part over the whole. So we're interested in graduate school, so we want to find the total number of students attending graduate school. So we're going to take the male students and add the female students. So that's the 1349, and we're going to add the 1954. And that's going to give us our total number of graduate students. When we add these, we get 3,303. So we have 3,303 graduate students total. So given that, we want to find the probability that we have a female student in graduate school. So we're going to look at our number for female graduate students, which is 1954. So that's the part that we're interested in, and we're going to put it over the whole. So probability of female given graduate school is going to equal the number of female students in graduate school, which is our 1954, and we're going to divide by our total number of students in graduate school. So our 3,303. Now you can plug this into your calculator and get out a decimal, and you should get 0.59. And again, remember that we can put this into a percentage by multiplying by 100. So we'll get 59%. So of the 3,303 graduate students, 59% of them are female. So we could also use the table to find another probability. If, say, we wanted to find the probability of students in 4-year college given that they're male. So this time, our total set is going to be the total number of males. So this column right here. We're interested in the number of males. And then we want to find what percentage are in four-year college. So to get our total, we're going to add up all the numbers of males. So we're going to have 18, 66, 43, 24, and 13, 49. And we're going to add all those up, and that's going to give us our total number of male students from this column. So we end up with 7,539 male students. So that's our total. So we're going to put our total, 7,539. And now we're interested in the percentage that are in four-year college. So we're going to take our four-year college number and put it on top. That's the part that we're interested in. So part over the whole. So we have 43, 24. And again, we're going to plug this into our calculator. And we should get approximately 0.57, which translates to 57%. So of the male students, 57% are attending a four-year college. All right, and now down to problem 2. Problem 2, we're going to do the same thing. We're given a table, and we need to interpret what we're asked for. So it says Americans recycle increasing amounts through municipal waste collection. The table shows the collection data for 2007. What is the probability that a sample of recycled waste is paper? So first we have to figure out what probability we're actually finding. And this is a conditional probability. So we want to find the probability that a sample of recycled waste is paper. So given that it's recycled, we want to know what percentage is paper. So that's going to be wrote as paper given recycled. So we know that our sample is recycled, and we want to know what percentage of that recycled is paper. So like in the previous problem, we're interested in the recycled column. So we're going to add this column, and that's going to give us our total. So our total is going to be 79.4 when we add up that whole column. So our total, our bottom part of our ratio is going to be 79.4. And then we want to know which percentage is paper. So we're told that 45.2 is paper, so we're going to put that 45.2 over our whole. So again, part over the whole. And again, we're going to get out a decimal. And you're going to get approximately 0.57. And again, changing that to a percentage gives you 57%. So of the recycled waste, 57% of it is paper. Now in problem 3, we're going to actually use the equation, or the formula. So problem 3 says, a utility company asked 50 of its customers whether they pay their bills online or by mail. What is the probability that a customer pays the bill online, given that the customer is male? So ultimately, we're looking for probability of online, so that they pay their bill online, given that they're male. So that's ultimately the conditional probability that we're looking for. So if we're going to use the formula, we have to find the probability of event A and B. So being male is event A, and paying online is event B. So we need to find probability of event A and B, which would be male and online. So to find the probability of being male and paying online, we look at the male column, and this is the number that pays online, so there's 12. And then this 12, remember, for probability is out of our whole. And we had 50 customers to start out with. So the probability of being male and paying online is your 12 out of 50. Because you have 12 males that pay online, and that's out of your original 50 customers. Then we need to find the probability of event A, which is the probability of male, of being male. So for this, we're looking at our male column. So we have 12 and we have 8. Because we have 12 males that pay online and we have 8 males that pay by mail. So 12 plus 8 gives us 20 males altogether. And that's out of the original 50 customers. So our probability of being male is going to be the 20 over the 50. There are 20 males out of 50. So now, to find our probability, our conditional probability, so our probability of online given male is going to equal the probability of A and B. So the probability of male and online divided by the probability of being male. Because that's what the formula said. So if we plug in our values, we have, for probability of male and online, we have 12 over 50. And then that's going to be divided by the probability of being male, which was 20 over 50. So we have a complex fraction, and you can either plug this into the Inspire the way it is, using the fraction keys, or we can simplify the complex fraction, which would be 12 over 50, and then remember we flip and multiply this bottom fraction. So we're going to multiply by 50 over 20 if we flip and multiply the fraction. So our 50s are going to cancel out because we can cross-cancel in this problem. And then we're going to divide both of these by 4, so we're going to get 3 and a 5. So we're going to end up with 3/5 is our reduced fraction that's left. And again, you can plug this into your calculator and get out a decimal. And you'll get 0.6. Which you can also change to a percentage, which is 60%. So of the male clients, 60% of them pay online. So that's what we found. Now, for number 1, now we're going to use our conditional probability for rolling dice. So what is the probability that the total of 2 dice will be greater than 9, given that the first die is a 5? So we're told that event A is that the first die is a 5, and then we're told that event B is that the total of the 2 dice is greater than 9. So if we want to find probability of A, that's the probability that the first die is a 5. Well, there are 6 choices, because we're looking at rolling 2 dice. So there are 6 different possibilities of when we can roll a 5. We could roll a 5 and a 1, a 5 and a 2, a 5 and a 3, so on. So there are 6 different choices of when we could roll a 5. So we have 6 is the part that we're interested in. And then over our total set, which is this whole chart, there are 36 different ways we could roll the 2 die, or the 2 dice. So we have a 6 over the total set, which is a 36. And then remember, we can reduce this fraction, so that'll be 1 over 6. So then we also want to find the probability of B, and event B is that the total of the 2 dice is greater than 9. So if we look at our chart, we're going to find all the values that are greater than 9. So we've got one here, 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 and here. All those circled values are greater than 9. And those are the only values greater than 9. And we have 1, 2, 3, 4, 5, 6 of them. So again, we have 6 out of 36, which reduces to 1/6 again. So now we want to find the probability of A and B. So looking at our choices, we had the 6 different choices for when the die was when the first die was equal to 5, but we want it to be also when the total of the 2 dice is greater than 9. So if we're looking at this column, we have 2 choices that are greater than 9. So this is A, and then this is and B. So 10 and 11 are your only 2 that are greater than 9. So we have 2 choices that are A and B. They follow event A and event B. And that's again out of our total of 36. So there are 2 out of 36 that are both A and B. And again, we can reduce this fraction, and that's 1 over 18. So now we're going to use these values to find the probability of B given A.